My name is Nick Campbell, as Chris said, and I work for Axiom Software, and my Twitter handle is ncboit. Those are zeros. Today I'm going to talk about Timmy. I'm going to tell you a story. Also, any design work you see in here, I'll freelance for you. I'm a wizard with Microsoft Paint, so feel free. Timmy's a developer. And Timmy was told to write a web application. Timmy has to create models in his database. He found that his schema was rigid and stiff, and it was hard to change. And integrating search proved to be a challenge. Plus, Timmy was used to working with JavaScript, and switching tracks was kind of a pain to him. Over time, he became displeased with his templates and the fact that it was more just copy and paste. He really couldn't get away from the tag soup that the current frameworks lent. Timmy was a sad panda. So the current situation, or the situation that was about when we started developing Axiom Stack, was that you really had to know all of the database schemas, the properties, fields, things like that, that you wanted to actually expose to a web application. It became a challenge to modify those schemas when the application actually changed and when your requirements, the specs of a web application changed for, a customer or client, your own needs. Also, search became an interesting challenge to integrate. You had to deal with full text searching, indexing correctly with relational database systems, and then once you got there, you had to also build in stemming, stop words, things like that, that really give search engines some power. Plus, existing systems required you to always context switch. You always had to go from JavaScript, which is interactive, the web, this is what we all associate with the web, and then move to Ruby or Python. One of the systems that I was working with was Zope. And so that provided unique and interesting situations when I was trying to switch back and forth between the Python and the interactive side, which was the web. And then you specifically with Zope and other frameworks that existed, you got to deal with tag soup, where not the conventional thoughts of putting in invalid HTML into your template for the presentation layer, so when a user actually saw your page, the page wasn't completely correct in terms of the W3C. I'm talking more on the server side, where you're putting in actual business logic to your templates. This doesn't lend itself to reuse, and the fact that they're so invasive makes it hard to maintain later on. So let's go back to Timmy. Coworker Karen saw that Timmy was down. Timmy told her what was wrong. He wanted a web framework that could grow with the project. Timmy didn't want to have to rebuild his databases every time he needed to change his schema, every time a new field came up. And he wished that search were easy, not only on the site, but also from within the code. He wanted separation of layers to be able to write the code once and have less of it. Timmy realized that his code is hard enough to maintain, and he didn't want to mix it into his templates. So the current complications. So this current meaning now, right? Data sources. The current convention with systems like Rails and Django is when you change your schemas, when you change the fields that you have, you need to migrate your database. And so then you are required to go out and run scripts to fix up your database. And that can be, although it's relatively easy, right? They're scripts that are done for you. Over time, you lose a decent amount of time having to go back and update the tables and the databases and run these scripts. And you should be able to expect more from your data source. You should be able to expect that you get high-power search functionality out of the box. With existing systems like Rails and Django, they tell you to use Zapier or Sphinx to integrate search with your application, and at least in our opinion, that should be a part of the application framework. The framework that you're using should be simple, and you should be able to use the same data structures and the same object structure that you're using in the interactive web with the back end, right? Instead, now you're required to bring in external libraries for Python or PHP to actually expose the data externally. And you should really be separating your business logic from your presentation layer. You basically want to leave your tag soup at the table, right? You don't want to bring the business logic into your code because it, as Timmy found out, doesn't lend itself to reusability, and the maintainability becomes a problem. So Karen smiled. She said, I have a solution. Karen showed Timmy Axiom Stack. Karen explained that Axiom Stack is a web application framework for server-side JavaScript. In Axiom, your models are called prototypes, and your schema is dynamic. As soon as the data is saved, it's searchable within Lucene. You can use the search API to access your objects, and because it uses the Rhino engine, you can write JavaScript all the time. And one of my coworkers said yesterday that this is probably the only conference that I would get away saying that. Karen also showed Timmy that templates were a snap. With only a few attributes, you can keep the logic out of your templates and in the JavaScript functions where they belong. So here's our resolution. This is a 1,000-foot view of the Axiom architecture, right? Our web server technology is Jetty. And what we do is allow you to build prototypes. The prototypes are made up of security, functions, templates, and a schema. And the back-end technology by default is Lucene. But we know that there's necessity for having legacy systems, right? Everybody has legacy data. So if you already have data in a MySQL database, Oracle, that sort of thing, then you have that accessible to you. And we're also working with the folks at 10gen to integrate the MongoDB as well. And I'll get to that in a second. basically, with Lucene being our back-end data system, we get really high-power search, and all the features of their indexing system to create these dynamic schemas, because they're a schemaless document system, much in the same way that the CouchDB system is, although the feature sets are very different, but the premise is there. And the thing that's nice about that is that you get the ability to grow your application as the requirements change for that application. With the relational system, there's always a need for a relational database, right? Right now, you've got specific functionality, such as counting and the functions that exist within those databases that make accessing your information very fast, and providing you with really fast analysis on the data itself. So what we're looking at with Mongo is the fact that they're trying to take the features from Lucene, such as the schemaless documents and the features from the databases that are good, and combine them together. And so that's the purpose for Mongo. Search, I touched on this a little bit, but the way that search works is that all the data is stored in a reverse index in Lucene. And what we've done is basically exposed an API, which we call the query API, to get at your objects. And by objects, I mean the documents based on the prototypes that you built before. And this query API works both with Lucene and the relational model and so on. But basically, all you do is you tell the query API which prototypes you want to get back, and you pass in a JSON and detailing the field and the actual terms you want to search for, and you get your data back. So you can then display things like navigation, search results, and all of that, all in a single function, all very fast. And you can focus your efforts in JavaScript. You can basically write JavaScript all day long. You get access to the JVM through Rhino, and then so if you've built jars or Java libraries that have specific functionality that are necessities for you. For instance, we're working on an application right now that uses the Amazon Web Services, Flickr, and a few other external services. We can basically use the Java APIs with the same the Java script constructs, all from within the JavaScript functions. And then the templating system we use is a system that we came up with. We weren't really happy with the DTML that we were working with, and if anyone's familiar with it, would probably understand why. It's completely intrusive. It's not easy to read, and so what we did is expanded upon the new templating system that Zope was coming up with, called Tail, and they called it Tal, and we're calling it Tail, which is Tal enhancements, or extended, basically. And so what we do is, with a few simple attributes to your elements, allow you to create all the functionality that you need to display anything in the presentation layer that you would need, but not be intrusive to your code, or not be overly intrusive to your code, as the other systems that I've worked with are. and all the attributes that you add in are removed before it goes out to the user in the web page. So if you're viewing source, you wouldn't see any of these attributes. And then these templates are reusable as well. You can basically pull in other templates through a system similar to including templates, so that you can basically write your template once and reuse it in multiple places. So back to Timmy. Timmy began to smile when Karen enlightened him to this. Timmy went on to do great things with Axiom Stack. And Timmy was happy. So I appreciate you coming out. If you have any questions for me, I can answer them now. And I'm planning on doing a thing tomorrow in the track B portion on server-side JS, show you some code and that sort of thing. So, anyone have any questions?
Why extend towel instead of using something like Pure? I mean, I'm not really familiar with the JavaScript template languages that are available.
Instead of using what?
Pure.
Pure. I'm actually not familiar with it. But the reason we went with towel is because when we were first coming up with the templates, we were basically trying to create a system that fit our notion of HTML, which was the stricter XHTML, and then make it so that it was as simple as possible to modify the actual templates, to get your functionality to happen, but keep the ability to go overboard out, because that's generally what happens right now, right? With templates, you have the ability to go way above and beyond what you may mean to when you are first creating them, and so we basically nailed down the necessary directives. You can repeat over an array. You can iterate over an array. You can push content into an element, so creating child text nodes and things like that. But it really creates that separation of the business logic and the actual presentation layer.
What were the extensions that you had to do to Tau?
We actually didn't do extensions to Tau. We rewrote the parser in JavaScript. And initially, we had the implementation called Tau that we basically, we weren't huge fans of it and moved to this enhanced version, which does the specific things that we need. So by that, I mean we can basically run JavaScript functions. We can, you can do API calls, things like that, from within the attributes. And our original implementation didn't support that. So it was basically anything that was passed in the scope was available to you. Now, anything that isn't within the scope can still be accessible to you. You just need to call the APIs that you created.
Does this run in V8 or SpiderMonkey or any of the other JavaScript engines?
Not yet, but yet is the keyword. I'd love to enhance this to basically get it going into other areas that we haven't touched yet, and benchmark them, see how does the Rhino implementation perform against SpiderMonkey and that sort of thing.
Is there any special parts of Axiom that allow you to more easily do like remoting from the client, whether Ajax call and things like that? Is it automatically built in, or is it the same kind of Ajax that you do?
It's the same normal Ajax that you'd normally write. I think you might be referring more to the way that Jaxer does it, correct? If I'm not mistaken, that's similar to their model. And the way that we're doing it is your functions are the actions. So with those prototypes that I was talking about, you would create your JavaScript functions inside of JavaScript files. Those JavaScript files then get loaded onto the prototypes and are available to both use from the code side, and then they become available as functions or actions that you can hit from a URL. So for instance, if I had a home page at / and off of that home page I had a function called hello world, I can access that function directly from the web. And so that's how you would do the AJAX as well. Basically, if you wanted to return a JSON or XML, and I'm actually going to talk about XML in a minute because I kind of forgot that. But if you wanted to do JSON, then you just return a JSON, and it would go into your JavaScript on the client side. And assuming you set up the MIME types and whatnot correctly with the library you're using there, it would parse correctly. Now, getting back to XML, one thing I sort of left out because it's not so much a feature of Axiom, but it's a feature of Rhino, is E for X. And that's basically XML as a JavaScript object. So what you get is the ability to drill down into XML objects using it's sort of a cross between JavaScript and XPath syntax. Although you're not using slashes, you're using dots and things like that. But you basically get the ability to manipulate your XML from the server side and then return that, and it'll be serialized as it goes back out. Thank you.